So, have you ever sat down for an exam, stared at a question you literally know for a fact you studied, and just completely blanked? Or maybe you met someone new, shook their hand, and 5 seconds later, poof, their name absolutely vanished from your mind. Yeah, we have all been there. It is a universally frustrating experience. But here is the good news. You're not broken. Today's explainer is all about the actual mechanical processes of memory. We're going to look right under the hood to understand exactly how we remember, why we forget, and how you can actively upgrade your mind. I want you to think of this explainer as a user manual for your mind. Let's kick things off with this idea. Remembering and forgetting are literally two sides of the same coin. It's incredibly important to establish right out of the gate that forgetting isn't a personal flaw. It's not a sign of low intelligence. It's really just a breakdown in a highly structured three-step system running in your brain. Every single time you successfully recall something, your brain has taken information in, held onto it, and pulled it back out. When any one of those specific steps fails, well, that's when you forget. Today, we're going to break this down into 4 key areas. First, the 2 sides of memory. Second, the information processing approach. Third, the 4 causes of forgetting. And finally, upgrading your memory. Let's jump right in. Starting off with Section 1, the 2 sides of memory. We really need to understand the fundamental mechanics of how a passing thought actually transforms into a permanent memory. The crucial thing to remember here is that this is a strict assembly line. It's got 3 distinct stations. First up is encoding. This is where your brain takes incoming raw information, say the spoken words of a poem, and converts it into a format the brain can actually use. Usually this happens by you paying close attention and giving it some sort of meaning or rhythm. Next is storage. This is holding onto that encoded information over time. Think of a child keeping multiplication tables safe in their long-term memory for years. And the third station is retrieval. That's pulling the stored information back out exactly when it's needed, like writing down a specific formula during a test. And here's the catch. All 3 steps have to work perfectly. If you don't encode the poem, or you fail to store the math formula, or you just can't pull it back out, that is when forgetting happens. Moving right along to Section 2, the information processing approach. It helps to think of your brain as a computer that's equipped with 3 very distinct hard drives, all based on time and attention. First, you have your sensory memory. This holds raw visual or auditory input very briefly. Think of that quick afterglow you see right after a camera flashes. That lasts for barely a second. Now, if you actually pay attention to that input, it moves to your short-term, or working memory. This holds a small amount of actively used info, kind of like a phone number you're about to dial. But it only lasts about 15 to 30 seconds unless you're actively repeating it in your head. Now, if you do rehearse it and process it meaningfully, it gets saved to your long-term memory, and this is the big one. This stores information anywhere from a few minutes to your entire lifetime, like your own name or your childhood address. Which brings us to Section 3, 4 causes of forgetting. So if this mental computer system works so well, why do things still go wrong? Let's look at the system errors, the specific reasons our mental computer crashes. The first one is decay. Sometimes the hardware just naturally decays over time if you aren't using the information. Imagine vocabulary words you learned in a language class a year ago. If you haven't spoken a word of it since, those memory traces are going to naturally fade away. The second cause is motivated forgetting, which is also known as repression. Think of this as your system's defensive firewall. Unpleasant or highly anxiety-causing information is unconsciously pushed completely out of your awareness just to protect you. It's a lot like a child unconsciously avoiding the memory of getting a really harsh scolding. Another major glitch we face is interference. This happens when old and new data actively compete with each other in your brain. On one side, we have proactive interference. This is where your old knowledge acts like a giant roadblock and completely stops you from learning something new. On the flip side, there's retroactive interference. That's where your new learning reaches back and essentially overwrites the old data. A classic example of this is when learning a brand new phone number completely blocks your ability to recall your old one. The new data simply interfered with the old pathway. And the fourth system error is retrieval failure. Honestly, this is the one that drives us all crazy. The information is perfectly stored inside your brain, it's totally safe, but it absolutely cannot be accessed because the right cue or context is missing at that exact moment. This is that agonizing feeling when you blank out on an answer sitting in the exam hall, only to recall it effortlessly the literal second you walk outside into the hallway. The data was always there. The pathway was just temporarily disconnected because your environment changed. Finally, we reach Section 4, upgrading your memory. Okay, knowing the glitches is great, but that's only half the battle.
Now it's time to install some critical software patches so we can actually strengthen our encoding, ensure safe storage, and build reliable retrieval queues. Our first strategy is chunking. Remember how short-term memory has really strict limits? Well, chunking helps you totally bypass those limits. It involves breaking large, overwhelming strings of information into smaller, highly manageable groups. So instead of trying to memorize a 10-digit mobile phone number as one massive string of random digits, you group them into blocks of 3 or 4. You are essentially formatting the data so your brain can process it way faster.
Next up, we use mnemonics. This is all about taking dry, abstract information and giving it a highly sticky, easy-to-retrieve form. You can use rhymes, mental images, or acronyms, like using the acronym VIBGYOR to instantly remember the exact sequence of colors in the rainbow. Doing this practically forces you to encode the information in a deeply meaningful, unforgettable way. We also want to completely change how we schedule our learning by using spaced practice. Instead of fighting your brain's natural limits, you need to work with them. Studying material across several short sessions spread over a few days is incredibly powerful. Revising a textbook chapter for just 20 minutes daily creates a drastically more robust and permanent memory trace than a frantic, exhausting 3-hour cram session the night before the test. It literally gives your mental hardware the actual time it needs to build those connections. Finally, we have retrieval practice. This is basically the ultimate system diagnostic. Just passively rereading your notes, that gives you a completely false sense of security. Retrieval practice forces you to actively test yourself. By solving practice questions or reciting a definition entirely from memory before you check the book, you are intentionally working out the exact neural pathways you're going to rely on when test day actually comes. Put simply, it all comes down to this ultimate formula: strong encoding plus safe storage plus reliable retrieval equals remembering. A weakness at literally any one of those stages causes you to forget. But by applying strategies like chunking, spaced practice, and retrieval practice, you aren't just crossing your fingers and hoping for the best. You are actively strengthening your brain's encoding and storage capabilities while building ironclad retrieval queues. So as we wrap up this explainer, I want to leave you with a question to ponder. Why does retrieval failure happen even though the memory is definitively stored in your brain? Think deeply about the specific contexts and cues your brain relies on every day and how you can actually start taking control of them in your own learning. Until next time, keep actively retrieving, applying these strategies, and constantly upgrading your mind.